what happens when tasks of different priorities try to acquire a single semaphore and are blocked? Who gets in front of the queue? Let's have a look. Okay, in this code, what we have is we have three threads: the LED red thread, the LED green thread, and a control thread. What does the control thread do? The control thread basically releases the semaphore every 5 seconds, all right? And the semaphore is basically used to control the access to the red LED and green LED. Okay, so similar to the lab where we have the push button to release the semaphore, now I am sort of replicating that behavior using the control thread. Only thing it is happening periodically every 5 seconds. Now, if you look at the LED red thread and green thread, basically what is happening is it waits for the semaphore, it tries to acquire the semaphore first, okay, and it waits forever. The initial value of the semaphore here is 0. Okay, so basically what will happen is it will wait. All right, so the LED red thread was the first one to be created over here, so it will be the first one to run, followed by trying to acquire the semaphore. And since it cannot get the semaphore, it will go to a block state, and the green thread will try to acquire the semaphore, and again it is not available, so it will wait. All right, when eventually the control thread runs, it will release the semaphore, and the first thread that was waiting, the LED red thread, will get to unblock and will get to run. Okay, so if you were to draw the timing diagram over here, okay, basically what you will observe is that the so I have a red thread over here, and I have a green thread. So what will happen is, and I also have a control thread. Okay, now since the red thread runs first, it will try to do the SEM take or SEM acquire, and since it cannot take the semaphore, the initial value of the semaphore is 0, you will go to a block state. So you will go to a block state over here, and similarly the green thread will be able to run since that is the next thread that was created. You'll also try to do a SEM take, okay, or SEM acquire, and again it is not available, so you'll go to a block state, and then and both of these are blocked. Of course, then finally the control thread will be able to run, and it will do a delay of 5 seconds. Okay, so it will do a delay, okay, of 5 seconds, and after that what it will do is it will do a SEM release. Okay, so when it does a Semaphore release, currently both of these tasks are in the same priority. So let me put it as a medium priority for both the tasks. So since both of them are in the same priority level, when I do a SEM release, the first task that was in the queue, okay, waiting for the semaphore, the red will unblock, okay, and you will be able to run. So it will able to acquire the semaphore, all right, once it is released, and then you will be able to control the red LED. Okay, and of course, then the next time when it goes back to the beginning of the loop, it will join the queue, and when this loop repeats itself, okay, after 5 seconds and it releases, it will go and allow the green LED thread to unblock and control the green LED. Okay, so that is basically the sort of behavior you can expect. Now, let's look at it over here. So I'm going to build this code right now. Okay, and then we're going to be running it. So let me bring up the camera over here. Okay, so let's run it and see it in action to confirm our understanding and the behavior to be the same. Okay, so I'm going to run it. So initially there is no LED blinking, all right, but after 5 seconds the control thread will release the semaphore, and then the red LED gets it, and followed by the next iteration where the green LED gets it, and so on. All right, so similar to what we saw in the class as well, okay, where I have alternating LED blinking one at a time. Now let me stop this and go back to look at it from the perspective of now changing the priority. Okay, so now the same thing as before. Okay, red LED created first, red LED thread created first, so it will run first, followed by LED green thread. Okay, but now what I'm going to do is I'm going to uncomment this line, the LED green thread, which basically sets the priority of the green LED thread to be higher than the red LED thread. All right, so the important thing to understand is the red LED thread was the first one to run, and it executed the Sempahore, correct? Which means it was the first one to enter the queue waiting for the semaphore. Okay, and right now we have the LED green thread that is coming after that, but now the priority has been raised, and now it is also trying to get the semaphore. So both of them are in the block state. Okay, so now if I were to draw it over here now, I have the red LED. Okay, so that is the first one to run, and it tries to do the Sempahore. Okay, it doesn't get it, so it goes to a block state. Okay, and the green LED runs, a green LED thread runs, and it also tries to do a Sempahore. Okay, so before it does a Sempahore, what happens is I increase the priority. Okay, so we can say that right now, I can say that the red LED is considered medium priority, while the green LED thread is considered a higher priority, correct? And after I raise the priority, okay, so this is the what happens after I start running the green LED thread. Okay, then I try to do a Sempahore over here, and again it is not available, so I go to a block state. Okay, so right now, if we analyze it from the queue, so the semaphore queue, okay, so the first person to join the queue was the red thread. Okay, because it tried to take the semaphore, but it was not available, so it went to a block state. Now, the next thing that happened was the green LED thread came in. Okay, the green LED thread came in, and it also joined the queue. But the thing is, the green LED thread is now higher priority. Okay, so what would happen is, okay, the green LED thread would overtake the red LED thread to be the first in the queue. Okay, so over here what will happen is the green LED thread will be the first in the queue, and the red LED thread will be pushed back because the green LED thread is now higher priority, and it is now trying to do a Sempahore. Okay, so when the control thread runs, okay, it will again do a delay, okay, of 5 seconds, and after that it will do a SEM release. Okay, so when it does a semaphore release, what would happen is, looking at the queue over here, the green LED thread is the one that would take the semaphore and be able to control the LED. Okay, so it will be actually transition to ready and run, and then be able to control the LED. Okay, and subsequently, all right, when it loops back, okay, and it does another Sempahore, all right, it will also be in a block state because nobody releases a semaphore until this delay is completed. Correct. So during that time, it already completed the blinking, and it goes back and does another Sempahore, which means it again joins the front of the queue. Okay, it jumps to the front of the queue, and it overtakes red, okay, in waiting for the semaphore. All right, so what you would observe is that the green LED is the only one blinking, because the red LED, though it was the first one to do the Sempahore, it was a lower priority thread, because the green LED's priority was raised after that. Okay, so the red LED never gets a chance to actually get the semaphore and run. All right, in this particular example. Okay, so let me show you the demo of that. Okay, so what I've done here is exactly the same code as before. Only thing is the green LED thread's priority has been raised after the red LED has acquired the semaphore. So always remember, the red LED thread was the first one to run, because when they were created, they were all created with the same priority, and the red LED thread was created first. So that was the first one to run and acquire the semaphore. Okay, and after that, the green LED thread was able to run. Okay, but the moment the green LED thread was put to run, okay, I raised the priority first, and then I acquired a semaphore. So both of them are now blocked, waiting for the semaphore to be released. Okay, but in the semaphore waiting queue, the green overtakes the red because of the priority. Okay, so let me build this and let me run it and show you what happens. Okay. Okay, so I've run the code. Okay, so as you can see, the green LED is the first one to blink, and subsequently, it is always the green LED that is blinking. Okay, the red LED never gets a chance to blink. Okay, so if I were to put a breakpoint, okay, so let me stop the code. Okay, let me reset it. Okay, and if I go back to my main, I can confirm that the Sempahore for the red LED runs first, and only the green thread runs after that. Okay, so let me run it and show you. Okay, so as you can see, the breakpoint first stops at red LED thread. Okay, that means the red LED thread is the first one to issue a SempahhoreAcquire, and then followed by the green thread. Okay, but because of the priorities being changed after that, the green LED thread is the first one to be able to execute and blink the LED. Alright, and subsequently you can see that I only stay in the LED green thread and never go to the LED red thread at all. Okay, because continuously I'm able to acquire the semaphore because of the priority. Okay, so this again I hope helps to clarify that in terms of semaphore, the behavior is such that the highest priority task that has been blocked waiting for the semaphore will always be the first one in the queue to get it. Alright, how about mutex? Alright, so I have another video on that. You can look at the link up above this video right now. Alright, so please click on that and look at that video to understand the mutex behavior. Alright, where I've done a similar demo with some changes in the code to show you exactly how it behaves when you have a similar situation with different priorities and you have a mutex controlling a shared resource. Okay, so thank you for watching this, and please check out the other video on mutex as well. Thank you. Bye.